Hey everybody. In class the last couple of days we've been talking about compound inequalities, working with compound inequalities, graphing them, solving them. Today we're going to take this skill and we're going to apply it to a geometric situation. The triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. This might seem a little bit confusing at first, but let's visualize it with a diagram. So here we have a triangle, and we'll label these sides A, B, and C, right? Now, just looking at this diagram here, it looks like C is the longest side. But even just looking at this, we can tell that if we add up sides A and B, those two sides should be longer than C, right? To go over this horizontal distance here. So the way we can write that is A plus B is greater than C. If we add the lengths of A and B together, it has to be greater than the length of C. Now this also applies to if we add A and C together. That has to be longer than B. A plus C is greater than B. Also, right? Same applies if we have B and C added together. That has to be bigger than A. B plus C is greater than A. So really this theorem gives us three different inequalities, gives us three different relationships. This triangle inequality theorem tells us a lot about what triangles can exist and which triangles can't exist. For instance, my first one here, I have 4.1, 1.3, and 8.4 as the sides. Can this triangle exist? The answer to this one is no. Because if I add up 4.1 plus 1.3, 4.1 plus 1.3, I need that to be greater than 8.4. But this is only going to give me 5.4, which is not greater than 8.4. Since this is false, the answer to this is no. This cannot exist. This next one we have over here to the right, 10.6, 4, and 5.6. Now, I know if I add 10.6 and 4 together, I'm going to get 14.6. That's greater than 5.6, right? If I add 10.6 and 5.6, I know that's going to be greater than 4. But if I add 4.0 and 5.6, that's going to give me 9.6, which is not greater than 10.6, but it should be. So this again is false. This triangle cannot exist, no. My third example, I have 8.8, 8.8, and 8. So let's check these. If I add up 8.8 and 8, that gives me 16.8. That's definitely greater than this. If I add up 8.0 and 8.8, these two, I know I'm going to get greater than this. And if I add up my two 8.8s, that's definitely going to be bigger than 8.0. So in this case, all three inequalities hold. Any way I add these up, two sides will always be greater than the third side. Our last one here, we can check. I know if I add these two together, that's 18.5. That's a lot bigger than 4. 10.5 plus 4, that's 14.5, definitely greater than 8. And then if I add up 4 and 8, that gives me 12. And 12 is bigger than 10.5. So once again, all three inequalities are true here. Anytime I add up two sides, it'll be greater than the third side. So this one is yes, this triangle can actually exist. Now, these problems can get a little trickier when we're actually trying to find a possible value for the third side of a triangle. In these types of problems, I think it's best to write out all three inequalities that can potentially happen, and then we can solve for x in each of them. So for instance, I know that 2.5 plus 8 has to be greater than x, right? And I can simplify this left side here. That will be 10.5 is greater than x. So that's one clue as to where we're going. 10.5 is greater than x, or x is less than 10.5. Now, I also know that x plus 8 has to be greater than 2.5. Now, to solve this one, I'm going to have to subtract 8 from both sides. And here I get x is greater than negative 5.5. But I know x has to be greater than a negative number, right? So this one actually doesn't give me a ton of information. Now, my final inequality, we have x plus 2.5 is greater than 8. Now this one, when I solve it, this will give me a positive number, minus 2.5. And I get x is greater than 5.5. So now the two inequalities that are going to really help me here, I can ignore this one because it doesn't tell me anything I don't already know. If x is the side of a triangle, it's going to be positive. I have x is less than 10.5 and x is greater than 5.5. So I can write this as 5.5 is less than x, which is less than 10.5. So here's my possible range of x values. X is between 5.5 and 10.5. We can set up the same thing over here to solve this problem. I know that 4.0 plus 5.6 is greater than x, so that's 9.6 is greater than x. Then I also know that x plus 4 is greater than 5.6. Here I have to solve, can subtract 4 on both sides. That gives me x is greater than 1.6. So that's another clue. And my third inequality, I know that x plus 5.6 is greater than 4. Now this is going to give me a negative number again. X is greater than negative 1.6. That's pretty obvious. We're dealing with a geometric situation here. We can't have a negative side length. So I don't really need that information. But I do need these two pieces of information. If x is greater than 1.6, I can write that like this. 1.6 is less than x, and x is also less than 9.6. So the length of side x has to be somewhere between 1.6 and 9.6. If you feel like you have the hang of this after those last two examples, feel free to finish up your notes and submit it through Canvas. But I'm going to go through these two examples here for anybody who feels like they just need a little bit more practice working on these types of problems. For my first example here, I'm going to start with 4 plus 8 is greater than x. I'll start with my two sides that I know. So I know that 12 is greater than x, or x is less than 12. Right? That's one inequality I know of. Now, I also know that x plus 8 has to be greater than 4. Now, I can already tell this is going to be another situation where I have x is greater than a negative number. Right? Doesn't tell me anything I don't already know. Now, our last inequality is x plus 4 is greater than 8. We subtract 4 from both sides. And this is going to be a little more useful. I have x is greater than 4. So the two things I need to know, I know that x needs to be greater than 4, and x has to be less than 12. So my final answer here is 4 is less than x, which is less than 12. That side of the triangle is somewhere between 4 and 12. Our next example, we can start the same way. 2.8 plus 2.8 is greater than x, and that's going to give me 5.6 is greater than x. Now my next inequality is going to be x plus 2.8 is greater than 2.8. Subtract from both sides, and we get x is greater than 0. Now, my third inequality actually, it's just going to be the same thing because my other side is exactly the same, 2.8. So really just switch those two sides, but it gives us the same thing. So I'm just going to once again have x is greater than 0. So here, these two repeat. So it's basically the same thing, x is greater than 0, and x has to be less than 5.6. So this inequality is going to look a little like this. 0 is less than x is less than 5.6. So that side is somewhere between 0 and 5.6.